In this second exercise, we will focus on slicing and the construction of our harness. Slicing is the process of isolating and analyzing specific portions of a program execution that are relevant to a particular input, typically the part that causes a crash or unexpected behavior. Slicing helps to narrow down the root cause of a bug or vulnerability, making it easier to understand and fix. This technique improves the efficiency of the fuzzing process by reducing the unnecessary exploration of unrelated code. In other words, when creating a slice, the goal is to ensure that only the code necessary for the fuzzing is running. For example, if you are fuzzing an industrial control system, you might want to focus on just the communication or control logic module to look for potential vulnerabilities. The approach will depend on how the code is organized and how the build system compile it. Referring to the documentation can help you to understand how different parts of the system interacts, making it easier to determine where to begin. To create a slice, you can comment out a necessary part of the code, only leaving the essential code needed to run the target. For instance, if a section waits for another module to start, but you are not concerned with this module, you can simply comment it out. Another key concept we will explore today is the harnessing. Harnessing involves the creation of a framework or script that allow the fuzzer to interact with the target program and feed it with specific inputs while monitoring its execution for crashes or unexpected behavior. Just as slicing isolates the relevant part of the code for testing, the harness ensures that only two selected code slices are properly executed during fuzzing. A well-constructed harness serves as an interface between the fuzzer and the program, ensuring that the fuzzer can focus its effort on the essential code portions, maximizing the efficiency of the fuzzing process and improving the chance of uncovering security flaw. For a good slicing, it's necessary a bit of knowledge of the program that you want to slice. And for this reason, in this exercise, we will use SourceTrail to explore our code. The first step is to download and install SourceTrail, and the fastest way to do so is to download it from the official GitHub repository. So we open the official GitHub repository and we move until the download link. Now we select the right version for our operating system, in my case Linux 64-bit, and we download the archive. Now we can extract it we move inside the extracted folder, and we can run the program using the sourcetrail.sha script. SourceTrail is a tool that helps us to understand complex code by visualizing how different parts of the code are connected. It works by first analyzing the source code and creating a graph that shows a relationship between functions, variables, and classes. This graph help us to track down how data flow through the program and how different pieces of code interact. SourceTrail does not run the code, but it uses static analysis to build a map of the code structure. It then allows us to explore the relationship in an interactive way, making it easier to navigate and understand even large code bases. The first thing to do to start using SourceTrail is of course choosing our target, that in our case is the exercise 3 from the fuzzing module repo, the same repo that we use in the first exercise. So this one is the repo, and we move inside exercise 3. Okay, now going back to SourceTrail, we can click on New Project and fill all the necessary fields, like the project name and the project location. As a project name, we can use whatever we want, for example, test. And for the project location, we can select where we want to save our project. Now we can click on Add Source Group and select the right option. That in our case, it's the C++ from compilation database. A C++ compilation database is a file that contains detailed information about how each source file in a C or C++ project is compiled. It is typically generated during the build process and provides all the flags, including paths, macros, and other compiler options that are used to compile each source file. This database is crucial for a tool like SourceTrail to understand the project's build configuration. Now, as suggested in the below comment, a compilation database can be exported from CMake using the following variable. So, before proceeding, we have to enable it in our CMake file. So we open our project, we open our CMake file, and we add the following line. So we set the CMake export compile commands to on. Please note that it's really important to put it right after the project name, that in our case it's drone. Now we can save it, go back to our project and compile it. So we create the build directory and we run cmake dot and make. And as you can see, now we have the compile commands.json file that contains all the information about each source file that is compiled. And we can open it also from there. This is our compile command JSON file. Finally, we can jump back to source trail, click next, select the compilation database, that is inside our build folder, and click create. Now we can start the indexing, and in that way SourceTree perform the analysis of our source code. Now we can play a bit with the tool and we can start looking for a good target or a good section of the code that we can slice and fuzz. So looking to the tool, we can see that it allows us to list all the files that we have in our program. We can list the classes and also the functions. We can start, for example, with the classes, and we select the specs class that contains all the specification of our drone. Now, on the left side, you can see an overview of all the methods, and on the right side, you can see the source code of the program. So, for example, we can select one of these functions, let's say the choose color, and on the right side, we can see the implementation of the function. Now we can see that, for example, if the color is a number, the program abort. So we can suppose that this can be a good target for our fuzzing process. So what we want to do is to understand how to call this function. And to do that, we can look to the graph, and we see that the choose color function, it's called in the main. So if we click on the main, we can see on the right side again the source code, and we can study how the choose color function is called. In our case, it's really simple because we just create a specification and then we call the choose color function.